Hello everyone, we are RATspace and this is our mega constellation design. So for our satellite constellation, as seen on the right hand side, we had 5 launches across 5 orbit planes, a total of 115 satellites. This was for maximum coverage and the most valuable latitudes were determined. For our performance measures, we had approximately 95% population coverage, and the total constellation cost about $1.1 billion and had a value of 31 spacecraft per million people on the right-hand side. You can see between the 2 red lines the total coverage across the world that we have.
So this was quite a complicated process, and so what we wanted to do is we wanted to simplify the problem before we started designing our constellation. One of the early assumptions and simplifications we made was figuring out what are the most valuable latitudes for our constellation so that we can trim and figure out how to design our orbits. So what we did was we sorted the latitudes from the data we were given and organized them by their population density, and then used that to inform our constellation design. So obviously constellations, we know, have our 6 orbital elements, and the ones that were most prominent here in order to design our constellation were semi-major axis and inclination. We wanted to reach the most valuable latitudes without going too far over that, and that's how we approached that portion of our problem.
And the end result was bringing continuous internet coverage to 95% of the world's population. To illustrate some of the steps we took to ensure that our design was as efficient as possible, we have a couple of plots here. The one on the left showing the value of every latitude based on the population. As is obvious from the graph, 88% of the world's population lives in the northern hemisphere and between those latitudes of about 58 and -58. To make sure that we hit those latitudes and hit the northern hemisphere as much as possible, we made our orbits slightly eccentric so they fly higher and spend more time over the northern hemisphere to provide greater coverage where we need it most. Finally, to make sure that we spent an optimal amount of fuel, we used this plot on the right to make sure that we got the minimum altitude we needed just to reach those latitudes, so that we're not spending fuel going any higher than we needed to go. We believe our design is as optimal as possible, and we hope you'll reach out to us at these contact locations.